Hey everybody. We are going to move on with some graphing. Over the last couple weeks, we have focused on graphing in vertex form. And we are going to go back to standard form and graph our quadratic equations in standard form. So just a reminder, standard form is y equals ax squared plus bx plus c. So again, this is the form we've been using since day one, really, of the semester. Okay, so the last couple weeks, again, we've been graphing in vertex form. Here we're going to focus in standard form. Now, the important thing as we graph is we need to find the vertex of the equation before we can create our table of values, right? So we've been finding our vertex, and then we've been choosing two numbers above and two numbers below that x value of the vertex so that we could create the rest of our table of values. Can't really do much else until we know what the vertex is. Now here's going to be the important part. To find the x value of the vertex, we are going to use negative b divided by 2a. Okay, to find the x value of the vertex, we're going to use negative b divided by 2a. And then real quick, does anyone remember what else the x value of the vertex gives us? So think back to all your key features in the last couple weeks. What does the x value of the vertex give you? Hopefully you are saying the axis of symmetry. So the x value of the vertex is also going to give you your axis of symmetry. Once you know what the x value of your vertex is, you're going to plug it in just like we do with our table of values to find the y value. Okay, so we're going to find the x value of our vertex. We're going to plug it back in to find y. You should be able to identify all key features of this graph. You may not always be asked to, but you should be able to. So in some of these, we may go through and find all the key features. In this first section, we're going to just focus on finding the vertex and the axis of symmetry before we create our table and graph. Okay, so we have the equation y equals negative x squared minus 8x minus 17. So before we start, we're in standard form, right? Ax squared plus bx plus c, and we're going to identify our a, b, and c. So this goes back to when we were factoring, when we used the quadratic formula, all of that. You should be able to identify a, b, and c. So a is the number in front of x squared. B is the number in front of your single variable. In this case, it's an x, so that's negative 8. And c is my constant, which is negative 17. Okay. Now we're going to take that information and help us find the x value of the vertex using negative b over 2a. So negative b over 2a is what we're going to use. The negative's a part of the equation or the expression. And I'm going to plug in my b, and b is negative 8. All over 2 times a, which is negative 1. Okay, so from there, I have a negative times my negative 8, which gives me a positive 8. 2 times negative 1 is negative 2. And if I simplify that fraction, I end up with a negative 4. Remember, this is the x value of your vertex. That's what you just found, the x value of your vertex. I need to find the y value. So I'm going to literally take negative 4 and plug it back into my equation to find y. Now here's where things get tricky if you're not careful with your signs and parentheses, so make sure you're writing everything out. So y equals, again, I'm just rewriting the equation, but plugging in negative 4 where I see an x. So there's already a negative in the equation, and then negative 4 squared minus 8 times negative 4 minus 17. All right, let's keep simplifying. So y equals, now order of operations says deal with your exponents first. Negative 4 squared right? Negative 4 squared, negative 4 times negative 4 is a positive 16. So this piece right here is positive 16, but I have a negative that I have to attach out front. Negative 8 times negative 4 is a positive 32. And then I have a minus 17 at the end. And you're going to do exactly what that says. Negative 16 plus 32 is a positive 16. 16 minus 17 gives me negative 1. And your calculator can help you do a lot of this. Okay, so my y value is negative 1. My vertex then is negative 4, negative 1. Axis of symmetry. Remember, it goes through the vertex, and it's always a vertical line, so x equals, and it's always going to match the x value of your vertex. Now, without graphing this equation, so I want you to say these things out loud, it's okay. Without graphing this equation, can you tell me what the orientation is going to be? So does your graph open up, or is it going to open down? Hopefully you said that it's going to open down, and remember, we're looking at our a value to determine orientation. So because my a value is a negative number, it opens down. Okay. Which means if it opens down, I have a maximum value. It's the highest point. My domain for all of my quadratic equations is all real numbers. And in this case, my range is going to be y is less than or equal to, because it starts high and it decreases. So y is less than or equal to the y value of my vertex, which is negative 1. Okay, so you should still be able to identify key features. Again, the nice thing about this is if you know your key features ahead of time, as you create your table of values and graph, if they don't match up, you know you went wrong somewhere. And so it's important to kind of keep that stuff in mind as we move through. All right, let's do another one together. Again, we're just going to find the vertex and the axis of symmetry. So let's identify A, B, and C. So A is 2, B is negative 8, C is negative 12. And I'm going to plug it into my negative, oh, you can't see that, negative B over 2A formula. Okay, so negatives in the equation, and then I'm plugging in a negative 8 all over 2 times A, which is 2. A negative, and then that negative 8 gives me a positive 8. 2 times 2 is 4, and when I reduce that fraction, I get a vertex. The x value of my vertex is 2. We're going to take our x value and we're going to plug it in to get our y value. So y equals 2 times, I'm literally copying the formula and replacing x's with 2. So 2 squared minus 8 times 2 minus 12. Order of operations. 2 squared is 4. So I really have a 4 times 2, which is 8. Negative 8 times 2 is negative 16 minus 12. 8 minus 16 is negative 8, and negative 8 minus 12 is a negative 20. So again, your y value is negative 20, which means your vertex for this problem is at 2, negative 20. My axis of symmetry is going to be x equals 2. It goes through the vertex at the x value. Again, I can name some key features based on the fact that my a value is a positive number. I know that my orientation is up. My graph is going to face up or open up. I also know that because a is greater than 1, I am going to have a stretch, which means my graph is going to get skinnier. Remember, we have vertical stretches and vertical compressions. Okay, so what I'd like you to do is take a moment, pause the video, and see if you can complete number 4. Identify the vertex and the axis of symmetry. When you have done that, go ahead and press play again, and let's see how you did. All right, so you've taken a moment to try this problem. I'm going to identify A, B, and C. So A is 1, B is negative 4, and there is no constant term at the end, which means C is 0. If I plug it into my equation, it's negative B divided by 2 times A. So negative, and that negative 4 gives me a positive 4. 2 times 1 is 2. And when I simplify, I end up with 2. So the x value of my vertex is 2. To find the y value, we're going to plug it in. Y equals 2 squared minus 4 times 2. 2 squared is 4. Negative 4 times 2 is negative 8. And 4 minus 8 gives me a grand total of negative 4 for the y value of my vertex. Axis of symmetry, x equals, remember it is a vertical line through the vertex at x equals 2. Okay, so I wanted to just practice finding the vertex in standard form, finding the axis of symmetry. We're going to now put that all together, create a table of values like we've been doing, and graph. Okay, so first things first, for our table of values, we need to know what the vertex is so we know what points to choose. So let's figure that out. First of all, A is 1, B is negative 4, and C is 8. We're going to plug it into negative B over 2A. So negative, and then negative B over 2 times A. Negative and a negative 4 is a positive 4 over 2 gives me a 2 for the x value of my vertex. I'm going to plug that in to get the y value. So let's see, y equals 2 squared minus 4 times 2 plus 8. So 2 squared is 4. Negative 4 times 2 is negative 8. And then I have a plus 8. Well, these are going to cancel out nicely, giving me a positive 4 for the y value of my vertex. Before I complete my table of values and graph, I can say that the axis of symmetry is x equals 2, right? The x value of my vertex. Can you tell me what the orientation is going to be? Hopefully you're saying up, right? So when I graph this, if my graph doesn't face up, I definitely did something wrong because my a value here is positive. So we're going to choose two numbers that are less than 2 and two numbers that are greater than 2. So two numbers greater than 2 would be 3 and 4. And two numbers less than 2 would be 1 and 0. You choose what you'd like to plug in. My hint to you is if you see 0 as a part of your table of values, I would plug it in for standard form because it's going to cancel a lot of stuff out for us. So y equals 0 squared minus 4 times 0 plus 8. 0 squared is 0, so that's gone. Negative 4 times 0 is 0. So all I'm left with is that positive 8. And remember, because of symmetry, if I plugged in negative 4, I'm going to get the exact same answer, so that is also 8. And then you can choose either 1 or 3 to plug in. Let's do 1. So if I plug in 1, I get 1 squared minus 4 times 1 plus 8. 1 squared is 1. Negative 4 times 1 is negative 4 plus 8. Oops, that should be like this. So 1 minus 4 gives me negative 3. Negative 3 plus 8 is a positive 5. So I can fill in those other 2 points as well. Okay. All right, last step is going to be to plot all those points. So 0, 8, 1, 5, 2, 4, 3, 5, 4, 8. We said at the beginning of this problem, because our a value is a positive number, our orientation should be up, which it is. So that kind of tells me we're in a good spot. I also know that a is 1, which tells me there's no change to my parent function. So it's not skinny, it's not wide, and it looks pretty normal, so that's good. But again, those are good features to help you identify whether or not you're doing this correctly. Okay, one more together. All right, number 2. Identify A, B, and C. So A equals 2 this time, B is a positive 8, and C is 0. I'm going to plug it into negative B divided by 2A. So negative 8 divided by 2 times 2. And in the numerator, we have a negative 8. In the denominator, 2 times 2 is 4. And when I reduce that fraction, I get negative 2. Again, we're going to take it and plug it in. So y equals 2 times negative 2 squared plus 8 times negative 2. Again, exponents first. And one thing that we were seeing as a mistake is when you square a negative number, it becomes positive. So negative 2 squared is a positive 4. Okay, and then I have 8 times negative 2, should be a negative 16. Ignore this, I scribbled that out. So that should be 8 minus 16, which gives me a grand total of negative 8 for the y value of my vertex. Our axis of symmetry is x equals negative 2. And now I'm going to look at my a value because I want to know what I'm kind of looking for before I create this table of values. So a is positive, which means my graph should open up. Okay. A is also greater than 1, which means I have a stretch, so my graph should be skinny. It's going to be skinnier than this graph here, but it's still going to open up. Okay, so let's see. I have my table of values where my vertex is at negative 2, negative 8. 2 numbers below are negative 3 and negative 4, and then I have a negative 1 and 0, which are 2 numbers above that negative 2. Again, plug in 0, because a lot of stuff's going to cancel out, right? So y equals 2 times 0 squared plus 8 times 0. 0 squared is 0. 2 times 0, still 0. 8 times 0 is 0. So if nothing's left, then we have a 0. Okay, and because of symmetry, negative 4 would also give me 0. I'm going to plug in negative 1. 2 times negative 1 squared plus 8 times negative 1. Negative 1 squared is a positive 1. Okay, so I really have 2 times 1 there, which is just 2. And 8 times negative 1 is negative 8, for a grand total of negative 6. All right, we're going to plot those points. So again, it should face up, that my orientation is up, and it should be skinnier than this graph here. Maybe not a ton, but it will be skinnier. All right, how about negative 4, 0, negative 3, negative 6, negative 2, negative 8, negative 1, negative 6, and 0, 0. Running out of ink. There we go. All right, that graph is definitely a little skinnier than the other one was. My orientation is up, so I'm good to go. All right, again, I want you to pause the video, and I want to see if you can complete number 3. You're finding the vertex, the axis of symmetry, create a table of values and graph, and don't forget to think about some of those key features to see if that matches what your graph should be. When you are ready, go ahead and start the video, press play, and let's see how you did. Okay, so you all have had a second to do that. I'm going to kind of just move through. So A equals negative 3, B equals negative 12, and C equals a positive 1. If I plug it into my formula, it's negative B divided by 2 times a. So that negative and the negative 12 gives me a positive 12. 2 times negative 3 is a negative 6. And when I reduce, I end up with negative 2 as the x value of my vertex. I'm going to plug that in to find y. So negative 3 times negative 2 squared minus 12 times negative 2 plus 1. Negative 2 squared is a positive 4, so I have 3 times 4, which is really a negative 12. And negative 12 times negative 2 is a positive 24. And then I have the plus 1 at the end. Okay, so negative 12 plus 24 is positive 12. 12 plus 1 gives me 13. So negative 213 is my vertex. Axis of symmetry is x equals negative 2. All right, let's look at A. So A is going to tell me what my graph's going to look like. So because it's negative, my orientation should be down. Because my graph's negative, my orientation should be down. Now I'm going to ignore the negative and I'm just looking at that number. Okay, so I have a 3. 3 is greater than 1, which means I have a stretch. My graph should be skinny. Okay, so not only does it face down, but it should be a skinnier graph. To fill in my table of values, 2 numbers less than negative 2 are negative 3 and negative 4. Greater are negative 1 and 0. We love to see 0, right? Y equals negative 3 times 0 squared minus 12 times 0 plus 1. 0 squared is 0 times negative 3, still 0. Negative 12 times 0, still 0, which means all I have left is a positive 1. And I'm going to plug in negative 1. Y equals negative 3 times negative 1 squared minus 12 times negative 1 plus 1. Negative 1 squared is a positive 1. So negative 3 times 1 gives me negative 3. Negative 12 times negative 1 is a positive 12. And then I have that 1 at the end. Negative 3 plus 12 is 9. 9 plus 1 gives me 10. Okay, again, my graph should face down. So as I plot these points, if my graph doesn't face down, I know I did something wrong. So let's see. Negative 4, 1. Negative 3, 10. Negative 2, 13. Negative 1, 10. And 0, 1. My graph faces down. It's definitely skinnier than that original graph. It's actually even slightly skinnier than this one too, because the larger that number becomes, the skinnier a graph's going to be. I have a maximum value, right? Because we have a high point here and everything's lower than. So our domain would be all real numbers. Our range would be y is less than, because it decreases, less than or equal to 13, because that's going to be the highest point I can go, but everything below that is lower. Okay, so even though we didn't focus a ton on key features in this particular section, you do want to make sure you understand the key features of the graph, because it will help you as we move forward, and it will be something that we expect for you to know as well.